This lesson is covering Lesson 16, which is solving problems with equations. We'll be looking at word problems and creating equations that can be solved from them. Starting with our first problem, it says, you know how to compute with rational numbers and write and solve one-step equations. Take a look at this problem. Mr. Lombardo took his 2 children to a water park. He used the coupon shown below to buy one adult ticket. The price of admission for all 3 family members was $76. What was the price of each child's ticket? It says this coupon is good for one adult ticket to World of Water at a price of $28, and you save $4. The very first thing that we should ever do when we're given a word problem is identify important information. Some important information within this problem is that we're taking 2 children to a water park. We're going to use a coupon to buy one adult ticket. The price of admission for all 3 family members, so the price for 3 was $76. And we're looking for the price of each child's ticket. Our coupon says that one adult ticket is $28. So all of this information, if you were just to focus on that, would state 2 children and one adult ticket. The price for all 3 is $76. We want to know the price of each child's ticket if one adult ticket is $28. We want to explore this problem. It first says in our first bullet, what ticket price do you know and how much is that ticket? We know that the price of an adult ticket is $28. And we know that because it says it on the coupon. In this case, our $4 tells us that originally our price would have been $32, but since we're saving $4, our coupon price today is $28. So the $4 is really extra information. What other information is given in the problem? We know that the total is going to be $76. And that $76 covers 3 people. And of those 3 people, 2 of them are children and 1 adult. So how can you find the price of 2 children's tickets using this information? If we know the total and we know the price of an adult, if we subtract them, then we'll be left with how much we paid for children. So we would subtract the adult price from the total. That would be 76 minus 28, leaving us with $48 spent on the children. Then it says, if you know the price of 2 children's tickets, how can you find the price of 1 child's tickets? Well, you would take the total for 2 and divide it by 2 to get 1. So the last bullet asks us, what is the price for each child's ticket? And show your work. If we follow the steps that we listed out, we would start with 76 minus 28, the total minus the cost of the adult, which left us with $48 for the cost of 2 children. We would then divide by 2 to get that it is $24 per child. If we then wanted to find out more, it says you can also solve the problem from the previous page by writing and solving an equation. You know that the price of an adult ticket plus the price of 2 children's tickets is $76. So if you take that statement and you say the price of an adult ticket, which is $28, plus the number of children, which is 2, times the price per child ticket, which is P, gives us the total cost of 76, then you can write this as 28 plus 2P equals 76. This equation includes 2 operations, so it's called a two-step equation. We want to solve the equation for P and compare to operations used in the arithmetic solution on the previous page. So the equation is solved for us. It says using arithmetic, the first operation was to subtract the price of the adult ticket from the total cost. That is what we did here. In the equation, you have to subtract 28 from both sides and simplify. Equations are made up of equivalent expressions, so we must keep things equivalent, meaning we must balance both sides. The second operation was to divide the price for 2 tickets, which was $48, by 2 to find the price for 1 ticket. So that is where we would divide by 2, and again, you must divide on both sides and simplify. You must keep things balanced. So to solve an equation, you perform operations so that the variable ends up alone. And when the variable ends up alone, we call that isolating the variable. So we want the variable to end up alone on one side. Remember, the expressions on opposite sides of the equal sign are equivalent. So if you perform an operation that changes the value of the expression on one side, you must or you need to perform the same operation on the other side. And the operations that we use to solve with are called inverse operations. So we use inverse operations to isolate the variable. And inverse just means opposites. In our reflection question, we're asked to explain the steps you could use to solve 3y plus 6 is equal to 30 to find y. If we wanted to solve this equation, again, we would have to use inverse operations. So we would want to subtract 6 from this side, making this equal 0, and whatever you do to one side, you must do to the other. We would be left with 3y is equal to 24. And then to figure out what 3 is multiplied by to get 24, we would divide. So you would divide by 3 on both sides. And again, when this cancels, you are left with y is equal to 8. So now the variable is isolated. So if we wanted to explain these steps, we would say first you subtract 6 from both sides. Leaving 3y equal to 24. Then divide both sides by 3 to get that y equals 8. We have another problem that now we want to read the problem below, then explore different ways to solve two-step problems that involve fractions. And fractions are no different than whole numbers. It's still important to read the problem and identify the important information. Marvin made some candles that each weighed 3/4 of a pound. He shipped them in a box that weighed 3 pounds. The total weight of the box filled with candles was 12 pounds. How many candles did Marvin ship in the box? So, as we read that problem, we should have identified that candles weigh 3/4 of a pound. the box weighs 3 pounds. The total weight of the box with candles was 12 pounds. So overall, we're looking to figure out how many candles did Marvin ship in the box. If we picture it, list out the information and really realize what's going on in the problem, you can use arithmetic to solve a two-step problem that involves fractions. We said that the total weight of the box and the candles was 12 pounds. That 12 pounds was identified here in the problem. The weight of the box is 3 pounds, and that 3 pounds was found here. So if we take the weight of all candles as 12 pounds minus 3 pounds, the candles weigh 9 pounds. That is information that was not originally in the problem, but we can find. So the weight of all candles divided by the weight of one candle, which we found in the problem, would be 9 divided by 3/4. And when you divide by a fraction, you are multiplying by its reciprocal, so that is really 9 times 4/3, which is 12. So we've now identified that there are 12 candles in the box. When we model this, that's actually setting up the equation. And anytime you set up an equation, you must establish a variable, because a variable is what you're going to solve for. So we want to let C represent the number of candles that Marvin shipped in a box. And we know that the weight of one candle is 3/4. We're looking for the number of candles, which would be C. So 3/4 times the number of candles will give us the total weight of the candles. And that plus the weight of the box will give us our total weight of 12. So now if we want to find the value of C, or get C by itself on one side of the equation, we would start by subtracting 3 on both sides, leaving us with 3/4 C is equal to 9. We would then undo the multiplication of 3/4 times C by dividing 3/4, and when you divide by 3/4, you are multiplying by its reciprocal of 4/3, leaving us with C is equal to 12. Next, we want to make some connections about the problem that we just did. The first question says, what is the first operation performed in the arithmetic solution and in solving the equation? And the very first thing that we did was take the total weight of the box, which is 12, and subtract the weight of just the box, which is 3. So this was the total weight minus the weight of the box. And when we took off the weight of the box, we were able to figure out the weight of the candles. So how does the first operation get you closer to isolating C on one side of the equation? And we actually just answered that. We now know only the weight of the candles. We're then asked, why do you multiply both sides by 4/3 next? Well, if you know that 3/4 times C is the weight times the amount of candles, then we're really needing to divide by 3/4. And when you divide by 3/4, you multiply by its reciprocal. So dividing by 3/4 is the same as multiplying by 4/3. We want to know, what does multiplying 9 by 4/3 represent in the arithmetic solution? When we multiply 9 by 4/3, we are solving to figure out the amount of candles that made up that weight. So we're dividing by 3/4. To find out the amount of candles that made up a weight of 9 pounds. So now we want to explain how to solve an equation that includes a variable with a coefficient added to a constant. In order to do this, you have to know that a variable is just a letter, or it's the unknown, what you're solving for. A coefficient is the number in front of the variable, or multiplied to the variable. And a constant is just a number. A number whose value is not dependent upon anything else. So in our problem that we are looking at, 3/4 C plus 3 equals 12. We are talking about 3/4 being our coefficient, C being our variable, and 3 being our constant. So if we want to explain how to solve an equation that includes a variable with a coefficient added to a constant, then we would subtract the constant from both sides. We then would divide the coefficient from both sides. And we're doing this in order to isolate the variable. You were asked to try the remaining problems for homework. You were asked to try 7 through 14. We're actually going to continue 7 through 14 in this video. In number 7, you're asked to solve the equation and show all steps in the solution. You are given the equation 2x plus 1 equals 5. I'm sorry, 2/3 x plus 1 equals 5. Using the terminology from before, 2/3 would be a coefficient, x would be our variable, and 1 would be our constant. So we would first want to subtract our constant from both sides. When you take 1 from 1, you're left with 0, which is why this disappears. And you're left with 2/3 x equals 4. You then want to divide your coefficient. So we would divide by 2/3. So 4 divided by 2/3 would be what we have on the right side. Now when you divide by a fraction, that is the same thing as multiplying by its reciprocal. So we would have 4, which is 4 over 1, times 3 over 2. You can cross cancel here. 4 and 2 are both divisible by 2, leaving you with 2 and 1. So now we have 2 times 3, which is 6, and 1 times 1, which is 1. So we're stating that x is equal to 6. And number 8, the formula converts degrees Celsius to degrees Fahrenheit. That is 9/5 C plus 32 equals F, or 9/5 Celsius plus 32 equals Fahrenheit. We want to use this equation to find the Celsius equivalent of 86 degrees Fahrenheit. So notice that we have two variables, C and F, but we know that F is 86 degrees. So you would use substitution here. We would have 9/5 Celsius plus 32 is equal to 86. We now would subtract our constant from both sides, leaving you with 9/5 Celsius is equal to 54. We then would divide by 9/5, and when you divide by 9/5, that is the same thing as multiplying by 5/9. So Celsius will be equal to 54 over 1 times 5 over 9. Here you can cross cancel. 54 and 9 are both divisible by 9, and 54 divided by 9 leaves you with 6. 9 divided by 9 leaves you with 1. So now you have 6 times 5, which is 30, and 1 times 1, which is 1. So we're saying that 86 degrees Fahrenheit is 30 degrees Celsius. Next we have a little bit more complex problem. It says Lydia is saving money for her vacation. So far she has $82.50. Each week she sets aside 25% of her paycheck for the vacation. After 8 weeks, Lydia has $338.50 saved for her vacation. We want to know what is the amount of Lydia's weekly paycheck. Again, we can highlight important information. She has $82.50. Each week, she is going to set aside 25% of her paycheck. We are going to do this for 8 weeks. And Lydia has $338.50 saved for her vacation, so that's like a total. We want to know what is the amount of Lydia's weekly paycheck. So you can use arithmetic to solve a multi-step problem that involves decimals. We're, again, listing out the information that we know and somewhat working backwards. So the total amount saved is $338.50, and again, that's found in the original problem. She has already saved $82.50, and again, that's in the problem. The amount she saved from 8 paychecks would be $338.50 minus what she already had. So she has saved $256 in 8 weeks. That's not information from the original problem. The amount she saved each week was $256 divided by 8. So she saved $32 each week. Again, that is not in the original problem, but we were able to find it with information from our problem. And the amount of her weekly paycheck is 25% of her paycheck. So if 25% is 1/4, and the amount that she saved is $32, you would multiply that by 4 to figure out that her paycheck is $128. If we were wanting to model this, we would want to list out the equation and then actually solve it. So you can write an equation to solve a multi-step problem that involves decimals. We know that the amount she already saved is $82.50. And we'll add that to her savings to get her total amount saved of $338.50. Now her amount of savings is going to be 8 weeks of 25% of her paycheck. So that's where all of this information is coming from. Now that you have an equation to solve, you're going to simplify both sides and then solve the two-step equation that remains. We know on the left side here, in this expression, we would start with 8 times 0.25, which would give us 2x. Now we're left with 82.5 plus 2x is equal to $338.50. According to our directions for a two-step equation, you need to undo what was done to the variable. X is multiplied by 2 and added to 82.5. Again, this is your coefficient. And this is your constant, even though they are not in the same order as what we saw the last couple of problems in. So in order to solve this, we would take the same steps. We're going to make some connections about the problem we were just working with. It says now you will solve the equation for the problem on the previous page. 9 says, what can you do to get 2x alone on the left side of the equation? Fill in the blanks to show how, and then simplify. So if we wanted the 82.5 to disappear on that side, we need to add its inverse, or subtract 82.5. And whatever we do to one side, we'll do to the other because we have to keep things equivalent. So we would also subtract 338.5 minus 82.5. That means on the left side of the equation, we would be left with 2x. And on the right side of the equation, we would be left with 256. In number 10, it says, what can you do to get the x alone on the left side of the equation? Fill in the blanks to show how, and then simplify. So if x and 2 are being multiplied, then the way that you would undo that is to divide the coefficient, which is 2. And whatever you do to one side, you also do to the other. So if you divide 2x by 2, you also divide 256 by 2. And when you do, you get that x is equal to 128. Our next question asks us to compare the arithmetic solution, where we listed out the steps, to solving with the equation. We want to know, how are the methods similar and how are they different? First, they're similar because you're still going to follow basically the same steps. You will still subtract and then divide. The main difference is when you did that with the arithmetic, that takes you to the weekly savings. Whereas when you do that with the equation, it takes you straight to the weekly paycheck amount. So the arithmetic takes you to the weekly savings first. Whereas the equation takes you to the paycheck amount. The next question asks us to describe how to solve an equation with 2 or more steps. When you're solving an equation with 2 or more steps, you have to keep in mind that all an equation is equivalent expressions. So you want to simplify the expressions on both sides of the equation first. Once you've done that, you're typically left with a two-step equation, and then you want to isolate the variable using inverse operations. Next, we want to try it again and solve some equations. We're told to use what you've just learned to solve these problems and show your work. First, in number 13, we have solve 0.06x minus 0.18 equals 0.12, or 600ths x minus 1800ths equals 1200ths. We first need to remove the constant, and we'll do that by adding 1800ths. Again, we use inverse operations. Once we do this, we're left with 600ths x is equal to, because negative 1800ths plus 1800ths is 0, and that will be equal to 3/10. So now we have 600ths x equal to 3/10. We now need to divide the coefficient because we want to undo the multiplication that currently exists. So now we will be left with x is equal to 5. Math is unique. You always have the ability to know whether you are correct. So in order to check your answer, take your answer and replace it for the variable in the original problem. So 0.06 times 5 minus 0.18 should equal 0.12 if we're correct. When we multiply 6/100ths times 5, we come up with 3/10. And 3/10 minus 1800ths should equal 12/100ths. And when you subtract 3/10 and 1800ths, you do come up with 1200ths. Therefore, because we have equal numbers, we are correct. In number 14, we want to solve 5 400ths minus 6x equals -6. This time our constant is at the front, but because our constant is positive, the way you would remove that or make it equal 0 is to subtract 5.4. And whatever you do to one side, you do to the other. So once this is removed, you are left with -6x is equal to 6 minus 5.4, which is 6/10. I'm sorry, I left off my negative sign. That's a common mistake made, so we should always double check. We have -6 minus 5.4, which leaves us with -11.4. Now we will divide by our coefficient, and our coefficient is a -6 here. Make sure that you keep that negative with it. Divide by -6 on both sides to keep things balanced, and you are left with x is equal to 1.9. Again, if we're correct, then when we replace our variable in the original problem with our answer, we should come up with an equivalent expression. So we would have 5.4 minus 6 times 1.9 should equal -6. And when you have -6 times 1.9, you come up with a -11.4. Bring down your 5.4, and it should be equal to -6. And 5.4 minus 11.4 does in fact give us -6. So since -6 is equal to -6, we are correct.